Alright, chem speak. That just means being able to look at our symbols of isotopes and know how many of each of the three particles of an atom there are. So first of all, atoms are naturally or usually neutral. That means they have the same number of protons and electrons. So the same number of positives and the same number of negatives would cancel each other, making it neutral overall. So when we talk about atoms, we talk about them being neutral. The atomic number is the number of protons, and that's what's found on the periodic table. So if we look at our periodic table, this number up here, the number above the symbol, that is the atomic number. So that's the number of protons. So we can take any element and know how many protons there are simply by looking at the periodic table. The periodic table is arranged according to the number of protons, so it goes in order. So if I say that there are 12 protons, then I know that the element is magnesium because magnesium is number 12. Isotopes are atoms of the same element then have different masses, and they have different masses because they have different number of neutrons. The protons are the same because it's the same element. It's the neutrons that are different. So different neutrons, different masses. The isotopic symbol is written like this, where X represents the symbol on the periodic table. If there's a number in the upper left corner, that's the mass number. The number in the bottom left corner is the atomic number. So sometimes that's there, sometimes it's not, because we can just look on the periodic table. So sometimes it's there, sometimes it's not, because we have access to it by the periodic table. And then C would represent a charge. So if there's nothing in the upper right hand corner, then it's neutral and your protons and electrons are equal. If there is a charge in the upper right hand corner, then the electrons are adjusted. So if there is a positive charge, that means you have lost electrons. If it's a negative charge, that means you've gained electrons, because remember, electrons are negative. So if you lose negative, then you're left overall positive. And then the mass number, that number in the upper left corner, the mass number is the number of protons plus neutrons. This is not found on the periodic table, so it has to be given to you. You're either given the mass number or you're given the number of neutrons, and you can add to the protons to get that. So again, looking at the periodic table, the only piece of information you can pull from the periodic table is the number of protons, because the atomic number is the number of protons. So here we have 4 atoms, and we're going to label or figure out the number of protons, electrons, and neutrons for each of them. All right, so if we look at number 1, the easiest thing to do is to find the number of protons first, because remember, protons are the atomic number. So we're going to go back to our periodic table and we're going to find Br. Br happens to be right here, so it has an atomic number of 35. So if the atomic number is 35, that means there's 35 protons. All right, then we can look at neutrons. So remember that protons and neutrons make the mass number. So if I want to find the number of neutrons, then I would just have to subtract my protons from both sides. So the mass number minus the protons are how you get the neutrons. Remember, mass number is found in the upper left-hand corner. So 78 is my mass number. So we would say 78 minus 35 and we would get our number of neutrons, 43. So we have 35 protons, 43 neutrons. Then we have to look at our electrons. If this is neutral, it would have 35 electrons. That way there's enough positive to cancel each negative. The charge in the upper right-hand corner tells you if it's neutral, negative, or positive. Well, because there's something in the upper right-hand corner, it means it's not neutral. So we don't have 35 electrons. It has a charge of -1, so it's saying you have an extra negative, one extra negative, and negative is electrons. So we actually have 36 electrons. So if it was neutral, it would have been 35. We have a negative charge, so we add electrons because electrons are negative. All right, now let's look at number 2. Number 2, we have Na dash and then a big 24. So this is not -24 because it's not written as an exponent. It's dash 24. This is another way of writing the mass number. So mass number can be found in 2 places. It can be found in the upper left-hand corner, or it can be followed after a dash. All right, again, the easiest thing I think is to find the number of protons, because the number of protons is the atomic number on the periodic table. So we're going to go back to our periodic table and we're going to find Na. That's sodium, which is right here. So it has 11 protons. So protons are 11 because the atomic number was 11. To find the number of neutrons, mass number minus protons. This time the mass number is found after the dash. So we would say 24 minus 11, and that would give us 13. Now to find electrons, we'd have to look and see if this is neutral or if there's a negative or positive charge. Because there's nothing written in the upper right-hand corner, there's no exponent in the upper right, this is neutral. So if we have 11 protons, we have 11 electrons, so that each positive cancels a negative. Okay, so then we look at the third example. We have mass number in the upper left. We have a charge in the upper right. We know the element is Ca, or calcium. So again, I think it's easiest to find your number of protons first. You go to your periodic table and you find calcium. It's right here. So it has 20 protons. So for protons, we're going to say 20. To find the number of neutrons, we would say mass number, which is 41 from the upper left-hand corner, minus the number of protons, and that leaves us with 21 neutrons. To find the electrons, if it is neutral, it's the same as the protons. But because we have this positive charge, that means it's not going to be 20. So if it was neutral, it would have been 20. The positive charge means we need to subtract electrons. So a positive 2 means I have 2 less electrons. So instead of having 20 electrons, I have 18 electrons. So neutral, like in number 2, protons and electrons are the same. A negative charge means you add that to your total electrons. Positive charge, you subtract from the electrons. So the electrons can change, the neutrons can change, protons cannot. All right, looking at our last example, 32p. 32 is my mass number. I'm talking about the element phosphorus. So I go to my periodic table, I find phosphorus, its atomic number is 15, so that tells me I have 15 protons, atomic number on the periodic table. To find the neutrons, I take the mass number in the upper left corner and I subtract my atomic number. So we have 17 neutrons. Then we have to deal with the electrons. There's nothing written in the upper right-hand corner, so that tells us it's neutral. And if it's neutral, protons and electrons are the same. So 15 positives, I would need 15 negatives to make it equal. All right, please make sure you fill out the Google form so that you can try a couple of these on your own.